Right, so for this proof of the perpendiculars in isosceles triangles, we're going to use the same idea that we used for the equilateral triangles, which is to create, use the perpendiculars and the areas that can be formed by that. So if we draw a line here, this point is very important because we can see AB equal to AC, so these two lengths are equal. Then we'll turn this point into an altitude of the triangle by joining this point to A, so that we've formed two triangles now. And we can see that here. So the big triangle ABC is equal to the two smaller triangles, the red triangle and the green triangle, their areas added together. Now we've got the perpendicular length, the perpendicular height I should say, of this triangle. So this area is going to be a half times that perpendicular length, which is BH, multiplied by the base. Now the base would be the length perpendicular to that, so this length here. We'll label that by convenience or convention with the lowercase letter for the opposite angle, or the vertex there. So that's the area of ABC. And we can similarly use the altitudes of the red triangle, so PF, and a half times, of course, the base length. Now this is an isosceles triangle, so these lengths are the same, so we can also call this length B, a half times B times by PF, plus, if we look at the green triangle, the base here is again the same length here, B, and the perpendicular length here we can describe as PE. And we're going to use the same idea here, that we can have a common term here of a half will cancel, because it's a common factor to all terms. B is also a common factor in all terms, it will cancel. And what we'll be left with is our result. And we're left with our result there, that BH is equal to PF plus the length of PE. So what does all that mean? So let's go back to the start here. What did we start with? What are these lengths? So we can see here that when we have an isosceles triangle, it's the perpendicular lengths from the equal sides meeting at this other length. If we add these two lengths together, it's equal to the perpendicular height from one of those two sides there. All right, I hope you enjoyed that.